Okay, I am here to do practice problem 2.7 from practice problem set 2, and I'm going to go through and do a couple of these tables where you have to use, we have two properties that allows you to find any other property. So remember that we've been learning about a lot of properties. In chapter 2 we only knew about specific volume, but now we've learned about internal energy and enthalpy. So with pressure, temperature, specific volume, internal energy, and enthalpy, if you have any two properties, you can find the rest of the properties. So in this case, we are going to start with A, where we have pressure and temperature, and we need to find specific volume. And just remember, this can work for any other property as well if you needed internal energy, enthalpy, anything. So we're going to go to the tables. We're always going to start with a saturated table. In this case, I'm going to go to the pressure entry because pressure was given at 1300, which is a nice round number. And I'm going to look at what the saturation temperature is at that pressure. So what does this mean? If I go over here to a TV diagram for this problem, we have specific volume, temperature, we have our phase boundary line here, which is the curve, and then I've drawn a constant pressure line at 1300 kilopascals. That pressure has a saturation pressure at 191.64, which is where this levels off here. So what this diagram is showing you is over here you have compressed liquid, anything to the right of the phase boundary. Over here you have superheated vapor, and anything in the middle is a saturated mixture. So for example, if you're starting with a liquid and you are increasing the temperature, eventually it's going to reach its saturation temperature, which is the boiling point temperature. At that temperature is when you're going to start getting vaporization. So you're going to have water converting to vapor, liquid water converting to vapor, and that's going to take a while of expansion until you're going to remove all of the liquid and be left with only vapor. So right here, you're all liquid, and right here, you're all vapor. F is for fluid or liquid, and G is for gas or vapor. And then if you keep increasing the pressure, once it becomes 100% vapor, then you're going to go along this superheated line over here and continue to expand the gas, which is why the specific volume is increasing. So in the problem here, it says that it's at 1300, but that the temperature is 400. So that means that on this constant pressure line, you are in the superheated region, somewhere over here. And so you are beyond the saturation region, you're all vapor, and you're in the superheated vapor region. When you reach that region, you are going to go to the superheated vapor tables instead of the saturated tables. The saturated tables are for any substance in this region between the nu F and nu G. You're going to look for 1300 kilopascals in this table, and for this example there's only a 1200 and a 1400 entry, so you're going to have to interpolate. But if you go down to 400 and look up the new value for 400 under the 1200 kilopascals, do the same thing under the 1400 kilopascals, the new value for 400 degrees C. We're going to write those two down for the two different pressures, and then we're going to interpolate. So since T is greater than T saturation, we're superheated vapor. So the information that we just looked up in the superheated vapor tables and this is T saturated. I'll just have this in here so you have it in your notes. So looked up 1200 and looked up that new value in the superheated vapor tables. That's what I just pointed to you for you. And then we looked up the 1400 values too. And we need P star, which is 1300. So we need the new value for that. So the interpolation formula looks like this when you have pressure and specific volume. So you should have this in your equation sheet. When you plug everything in, those were all given in the above lines, you will get 2363, and the units on that are going to be meters cubed per kilogram. So that can help you fill in that first table, superheated vapor, and the specific volume that wasn't given. So that's how you can find something that's a superheated vapor. You're going to go to the saturation tables, look at the range, and compare the temperature or pressure, whatever you're given, to determine if it's a superheated vapor. Moving on to part B, where we're given a temperature and a specific volume. Let's look at how you would do a problem like that. So here we're going to go to the saturated water tables, but this time we're going to go into the temperature entry. So for B, it was 160 degrees C. So we're going to go to 160, which is all the way down here at the bottom. And all that was given was a specific volume of 0.001. So we're going to look at nu F and nu G and see if that value is between the two. If it's between the two, it's a saturated mixture. So if you look, it's a little bit bigger than this one, but it's smaller than this one. So it is between the two. So we know it's a saturated mixture. So for B, nu was greater than nu F, but it was less than nu G, so it is a saturated mixture. So when it's a saturated mixture, you know that the pressure is just the saturation pressure at the temperature that you're interested in, and so you can just look at the saturation pressure in the tables, which is 617.8 kilopascals. I can show you that one more time in the book. So if you go to 160, the saturation pressure is 617.8 there. Okay, so that fills in that table value. The next one is a compressed liquid. So let me just show you how you can tell it's a compressed liquid with looking at the tables again. So part C gives you pressure and temperature. So I'm going to go to the pressure entry, and we need to look at 3,000 kilopascals. So again, I'm going to starting with the saturation tables, and I'm going to 3,000, and the saturation temperature at 3,000 is 233. So this temperature is greater than the saturation temperature. Sorry, the temperature is less than the saturation temperature. I can show you that on a PV diagram. Or I'll do a TV diagram again. So we just looked at a pressure equal to 3,000. And we saw that the saturation temperature for 3,000 was 233.9. And the temperature in the problem was 144. So that means that it was somewhere below the saturation temperature, which means it's in the compressed liquid region. So for this problem, you're going to want to go to the compressed liquid charts. And you're going to try to find 3,000 kilopascals. This is another tricky one because there's a 2,000 and there's a 5,000. There's no 3,000. So you're going to have to interpolate. And then the other problem is that for this one, there is not 145 in the table either. There's only 140 and 160. So I'm just going to show my work for this one on my other sheet of paper just so you can see it if you're curious. But you basically have to do double interpolation for this problem. So you can screenshot this and look at it. But you are going to have to do it at 5,000 between the two temperatures, do it at 2,000 between the two temperatures, and then interpolate again once you have the two pressures. Double interpolation. So I'll leave that up for 1 second. And then the last one I'll do, I guess I'm doing them all, huh? Is part D, where you're given, again, two different pressure and temperatures. And this one you don't have to interpolate, so let me just show you how this works if you don't have to interpolate. So for this one, 400 kilopascals and 650. So I'm going to go back to the saturated water entries. I'm going to go to 400 kilopascals right here. Oops, I'm a little bit too low. 400 kilopascals right here. And I'm going to look at the saturation temperature, which is 143.63. I'm going to draw my TV diagram again. In this case, I'm at P equals 400 kilopascals, and the saturation temperature is 143.63. The temperature given in the table right here was 650, so it's well above this line here, so you know it's going to be somewhere out here. So that means that it's a superheated vapor because the temperature is greater than saturation temperature at that pressure. So I'm going to go into the superheated vapor tables once again, and you're going to find 400 kilopascals, which is right here in this region, 400 kilopascals. Your temperature is 650, so it's going to be right in between these two values. So this one's easy. You could just take the average between the two, or you could interpolate. And when you do that, you will get right here. A new value of 1.06351. This one, the new value comes out to 0.001083. So I never actually finished that one. So you have four examples, one with a superheated vapor, one with saturated mixture, one with compressed liquid, and another saturated vapor example. These all involved interpolation. On a quiz, if it's close enough, you are always welcome to state that you're going to use the nearest table value. And you can do the same thing with internal energy and enthalpy. So I hope this helps. Always draw your PV or TV diagram to get you kind of oriented in what phase you're in. And good luck. Thanks.